Yes, sir. We can start recording us. Yeah.
Yeah. Very good afternoon to everyone. This is V S Rajashekhar, a PhD scholar at HIVE Lab, a Harmony Interaction and Versatile Exploration Lab at Department of Design from Indian Institute of Technology, Kanpur. Today, we will be having a hands-on workshop on Introduction to Robotics. Full name is Vachravelu Swaminathan Rajashekhar, shortly called as V.S. Rajashekhar. I did my schooling at Balalok Matriculation Higher Secondary School in Chennai. I did my bachelor's in mechanical engineering from Adhiparasakthi Engineering College, which is affiliated to Anna University in Tamil Nadu. I did my master's in SASTRA University, which is in Tamil Nadu, and I'm currently doing my doctoral degree at IIT-Kanpur. I have in between my master's and PhD, I worked at Tata Consultancy Services in the robotics group, IIT Hyderabad in the Robotics Research Center, and Tata Automation Limited in the Robotic Business Unit, and Indian Institute of Science, Bangalore for 4 years in the Department of Electronic System Engineering and Aerospace Engineering Department. My area of interest lies in the centered towards robotics. I focus mainly on mobile robots, bio-inspired robots, multi-body dynamics, manipulators, aerial grasping, computer-controlled robots, mechanism design, and compliant robots. These are a few robots which I have built in the past 10 years. This is the first robot which I built as a part of my bachelor's project. This is a snake robot which is capable of moving on a straight line and moving sidewise. And this is a robo which I built during my master's, which was 3D printed back in 2015 from TCS. And for this, we have the US and the Indian patent granted. So snake robots are my primary interest. Apart from that, I work on aerial grippers for drones and also modular robots which can be reconfigured to form various forms. And more interestingly, I work on robotic lizards because the snakes cannot climb wall, which can be tackled by using robotic lizards, which I feel is very important. And instead of using a rover in many situations, I plan to use a robotic scorpion, which has the ability to go over rough terrain. We'll be discussing about all these robots in today's session. And in during my PhD, I'm focusing on VR, that is virtual reality, where I'll be creating an environment where the robot would be performing its tasks. And this robo, which you see on the right, is a soft continuum robo for which the virtual environment is being created in the VR headset. This is MetaQuest 3. And in this headset, I'm trying to you control the robo using the headset and the joint and the hand controllers. So what to expect in today's workshop? I'll be briefly telling about robotics, basics of electronics, bio-inspiration, how you can take inspiration from biological creatures and create your own robots, usage of TRIZ. This is the art of problem solving and creating GUI, graphical user interface for robots. I like to pause at this moment and I like to ask the audience to think for a minute and tell me which I can focus on more so that you feel that it would be useful for you. You can interact with me now. Which portion you want me to focus more, or you're interested in learning more, or should I cover all the topics, giving equal importance to everything? You can unmute and you can talk. Are you able to hear me?
Yes, sir.
Okay, fine then. I think I'll cover all the topics which are here so that you will get a brief understanding of the overview of the qualitative aspect of robotics. So instead of just going into I'm sure that everyone knows what a robo is, and so I'm not going to explain what a robo is and the theory behind it. I'll just jump into the applications. So here is an application where robots are used for manufacturing purposes. It can be used for medical purposes. It can be used in defense for surveillance, as a substitute for soldiers and bomb disposals. It can be used for domestic assistance purposes. It can be used in the field of agriculture, space exploration, and underwater exploration. So before going into deep, we will now see a robo which was created by our DRDO in India, which is called as a Daksh robo, where you can this is the graphical user interface, and the robo is being controlled. This robo is capable of identifying, scanning, and destroying suspected objects. You can see in this video. So it is lifting up the object which is suspected. It is scanning the object for whether there is any explosive inside. It just destroys it using the shotgun. It can open doors which are locked also. So this is the robo which was developed by our DRDO, Defense Research and Development Organization. And here is a robo which is developed by Fanuc, leader in robotic arms, where this industrial robot is being used in Audi. So you can see the engine getting assembled. Okay. So the first question which everyone has in their mind when they start to explore robotics is, how can we explore robotics? How can I start building robots which are complex in nature? So for that, I would recommend an approach called as fix, crawl, walk, and climb approach. So in the fix, you mean that you have to try and make a simple manipulator, which using a cardboard and the servo motors which are locally available. And then you can see this video actually. You can use a manipulator. You can make a manipulator first, and then you can go for a crawling robo. And then you can go for a robo which walks using legs on a floor. And once you get command over this, then you can go for a robo which can climb up stairs. So this fix, crawl, walk, and climb approach will enable you to create more robots with confidence, because you will be learning stage by stage, and the mistakes which you do in the previous stage, you won't be repeating it in the other stages. So now I'll be showing you a robotic arm. This is an example of an open loop system. So here you start with the base, shoulder, arm, and the finger, but this is not connected to any of the body. So this is therefore called as an open loop system. So this robo is a simple three-axis robo, which I created for educational purposes. You can download the 3D model and you can try 3D printing it in your own lab, and you can try making the robo on your own. It's trying to pop a balloon with the pin which is there in it. So it's successfully popped the balloon. And this can also be used to lift very light objects, like a few grams. And this is how you can see it. And here is another robo, which is a closed loop mechanism, which follows a closed loop mechanism. This is a mobile robo, which is inspired by a gecko. So you can see the green portion, like a parallelogram, you can say. It's a 5-bar mechanism, 1, 2, 3, 4, and the base is the 5, which are connected together. So if you see this kind of robo, this is a closed loop mechanism. In robotics, if you see, there are either open loop mechanisms like this or a closed loop mechanism like this. So you have to define which category the robo which you are designing falls under. So what is an open loop mechanism and what is a closed loop mechanism? We can try to understand it with a better example. So everyone should have come across playing TT, that is table tennis, and everyone would have come across seeing people playing cricket. So the big difference between these two sports when compared to the open loop and closed loop mechanism is that the player in TT uses only one hand to hit the ball back. But in cricket, the player uses two hands to hit the ball. So here there is a closed loop which is formed in cricket, but whereas in TT there is only a table tennis, there's only a serial arm which is being used to play the game. So here the force which is applied, the torque which is applied is very less. But in closed loop mechanisms, like in cricket, the torque which is needed, the force which is needed to be applied is more, which we are getting using the closed loop mechanisms. So if you have any doubt till now, you can ask me. Okay. So what is the difference between the closed loop mechanism and the open loop mechanisms here in terms of error? Let's say in a closed loop mechanism, one link has bent due to application of force as due to aging. So this accuracy is lost in a closed loop mechanism. But this can be substituted by using various other techniques by either raising the pivot point over here, the O1. But in a serial mechanism, if a force is applied and if the arm is bent, this can still go by using the closed loop control systems, and it can go to the point where it needs to go. So this is available in open loop mechanisms, but in closed loop mechanism, the error correction is little tedious. Okay. Now we'll go into the basics of electronics. So has anyone worked on Arduino before? Or should I tell about the, okay, I see some hands raised up. So should I talk about Arduino's? Okay, tell it in brief for those who haven't gone through. For the next 5 to 10 minutes. So there are different types of Arduino boards, and this is the website arduino.cc, which is the official website where you can click on the download option, software option to download the software. That is the IDE, Integrated Development Environment. There are different types of Arduino boards, Arduino UNO, Arduino LilyPad, and DIY, do-it-yourself Arduino, Arduino Mega. So these are used for different purposes. Arduino LilyPad is used mainly in cloths. So if you want to have something embedded on some clothing or something, Arduino LilyPad is mostly preferred. Arduino UNO is very commonly used due to its varied functions. Arduino Mega is used when the number of input output is huge, like up to 40-45 pins. And this DIY Arduino can be made using the Atmel chip, which people can find in the market. So Arduino UNO, so this USB port, these are the components of the Arduino UNO. This portion is where the USB from the computer is connected to the UART, and this is the power in port which is used when the board is used in the autonomous mode, but when not connected to the computer. There's a reset button. There is a I2C buses over here. There's a digital input output pins over here for 14 pins. And there's a power supply over here and the analog inputs from the sensors over here. So these are the features which are available in Arduino. In short, it contains everything needed to support a microcontroller. You just simply need to connect it to the computer using a USB cable or power it with a AC to DC adapter or a battery to get started. So this is the IDE. The IDE consists of two things. In the program, there will be void setup, which will be run only once when you press the run option, and there's a void loop portion which keeps on running top to bottom again and again, so that it completes the function as required by the user. So input versus output. This is a simple thing I need not explain. You must be knowing about it. If there are transducers or sensors, you step on it, that is the input which you give to the Arduino, and the Arduino is connected to the computer, and the program is fed to the Arduino, and then from the Arduino, the actuator is something which is the motors or the buzzers which try to greet the person who is over here. So I hope everyone is using a laptop now. So we'll do some hands-on experience. We'll try to get some hands-on experience. But although if you have the hardware, it's well and good. If you don't have the hardware, don't worry. We'll be using a LED, a resistor, servo motor, a few jumper wires, and Arduino board. So this is how the jumper wires are connected to the Arduino board and the breadboard. The first experiment will be using Tinkercad for this. So what happens is, I request everyone to open Tinkercad if you're using a desktop. Are you following?
Yes, sir.
Okay. So this is a simple circuit where we are trying to blink the LED. So the LED is connected to pin number 12, and the ground of the LED is connected to the ground through a resistor. So what happens is there's a code over here. So what the advantage of using Tinkercad is that you have three options. Either you can go and code using the blocks which are already available, using the block. If you're comfortable with block kind of coding, you can use it, or you can use block plus text coding, or you can use the text coding which you are comfortable with. So if I click on start simulation, nothing will happen. The LED won't blink because we haven't connected it to this is connected to pin number 12. So you just need to change the pin number 12 over here and now start running the LED. So for 1 second it will blink, the other second it will stop. I hope you're able to see it. So if you want it to be high for 2 seconds, so this is in milliseconds. So 2000 milliseconds you can give, and you can make it blink for 2 seconds, on for 2 seconds, off for 1 second, on for 2 seconds, off for 1 second. So this is one example. So next example, we'll see the servo motor. I hope everyone knows what a servo motor is, and this is a common servo motor which is available in the market. So if you see in this, we are using two for loops, and before that we are attaching it to the pin number 13, the servo motor, and the position is changed from 0 to 180 and 180 back to 0, and there is a 15 millisecond delay between each angle adjustment so that the physically the object can move. So if you start the servo motor, it sweeps. It's basically a sweep program. So when you get out of the workshop, you can actually try to use the Arduino servo motor and the jumper wires to make the circuit like this, and type the code which is already there available in the sketchbook, and you can run the simulation. So in the sketchbook, if you see in file examples, servo and sweep. So this code will open, and you can try to upload the code over here. You can come verify it over here and upload it into the Arduino by connecting it to the system. Okay. So next, we will see a sensor. Since we have had a look at the servo motor and the LED, we will have a look at a sensor. This is a sensor which is called as ultrasonic sensor. The code for this, you can view it in the code section. But what I'm trying to show you is you just need to click on the sensor and the sensor will tell you it is for 44.7 inches away. That is 113.4 centimeters away. If you move the object in front of it, this sensor will send rays, hit the object, and it will come back so that it will tell at what level it is from away from the sensor, away from the object. So this is how the sensor works. Okay. So I'm going back to the. So apart from Arduino, there are various other boards which are available. You can find this interesting board called a Seed Studio XIAO ESP32C3. So this board is the size of your thumbnail, the size of your thumbnail, but it has the ability to transmit data wirelessly using Bluetooth and Wi-Fi. And there is a battery charging support facility which is also available in it. So this is a Indian 1 rupee coin, and this is the size of the spherical robo which I made, and this uses this microcontroller inside this. So you can make robos which are shorter, smaller than the tennis ball. So for this kind of purpose, Arduino boards are not that comfortable, but for that we can use Seed Studio XIAO microcontrollers for that purpose. Okay, we'll move to the next section of the talk. Before that, if you have any doubts till now, you can ask. Okay. Bio-inspired robotics. Why do we need bio-inspiration at the first time? Can anyone tell?
Because this is the future.
Okay, very good. Some other views?
So the world is made for humans. If we can make the robots humans as well, they can access all the things that we have.
Okay, very good. Okay. The biomimicking is a very important uh, aspect because of one main reason. The main reason is that we all came from nature and we took inspiration from nature from past millions of years, and that is why we are able to create something that is helpful for us. So in robotics, if we are able to solve things, if you on the screen you are able to see a human hand. People who are disabled without a hand, if we take inspiration from a person who has a hand and we try to make it a system out of it and a mechanism out of it, we can make a bionic hand for them, which will be a life changer for them. So this is a biomimicking robotic hand, which was published about 10 years ago, more than 10 years ago, but still this hasn't reached the market at a low cost. So we need to make low cost robots uh, which are useful for people who actually need them. So the biomimicry is important because we already, I'll be coming to how to do biomimicry a little later, but biomimicry helps you in achieving something which nature has already done. So we need, but we cannot control those animals. For instance, in this example, there's a robotic snake, which is my favorite area, but we cannot control a snake. Although people say this cyborg and things like that, but at the present, we cannot control these snakes. But these snakes have the ability to get into pipes. They can go inside. They can climb staircases. They can go inside rugged terrain, and they can do various activities. But taking inspiration from these and building these kind of robots will help definitely help in making robots which are have the ability to tackle human needs in a controlled way. So this is all uncontrolled. The biological creatures are all uncontrolled. You can train a monkey to pluck mangoes. You can train a monkey to pluck coconuts from trees. But the training cost is high, and the lifespan of the monkey and the ability to do it is very less. But you cannot do it on a mass scale. So that is a problem. But robotics comes as a solution, especially the bio-inspired robots come as a solution at that spot where the intersection between biological creatures and the human needs play an important role. So here is a snake robo. These are the snake robots which I have built so far for various purposes. This moves on a straight line and sideways. This can take a U-turn on a flat surface. This robot can move inside pipes, vertical pipes, top to bottom, not from bottom to top, but top to bottom. This robo is under development. These two robots I'm making it during my PhD period. This robo is made for earthquake surveillance, post-earthquake search operations. So you can see a wheel over here and a soft robo at the back side. So this is inserted into the debris so that we can find out whether people are there. If the void is big enough, we can attach the wheel to it and we can make the robo get inside the debris and search for survivors. So this kind of thing can be done only using robots which are sleek and long. So that is what is my presumption, and I am working on this area. And if you are interested to work on bio-inspired robots, you can take inspiration from other creatures also. For instance, JPL, Jet Propulsion Laboratory of NASA, they are also working on snake-like robots. They are also working on snake-like robots. This is for exploring other planets, especially the icy surface of moons of other planets, where the snake robot can move on the ice surface with good traversing capability. So this snake robots are the future. And that is what all the space agencies seem to be doing, because the European Space Agency has also asked the European countries to work on snake robots, and the NASA is also working on snake robots. And coming to the next creature, scorpion. Robotic scorpion is interesting because it has 8 legs, and at least one of the 8 legs will have contact on the ground, which will provide a contracting feature. And that other advantage is that it has the ability to grasp object in the front segment. So it can carry or manipulate, or it can pick something from the front portion, and it can carry it using the legs for locomotion. And for balancing, it can use the tail which it has. This tail can have 3 degrees of freedom, so that it can be changed to cater the need of the locomotion. Change to cater the need of the locomotion. So these kind of robots are also being used for in places where the wheeled robots cannot go. If the wheeled robot is stuck inside a plane, inside a mud or something, it is very difficult to get it out, I mean, especially in planetary, other planet explorations. But a robot which is similar to a scorpion can do the task very easily. Another robo which can be of great use for the oceans are the robotic fishes. If you see, this robotic fish is made up of several servo motors, a control system, sensors, battery, and a metal frame on the top. So this fish, the people are watching the robotic fish inside a fish tank in the country which it was made. But this fish is capable of detecting pollution in the port. So in the port, getting inside water and testing the water for pollution can be done using robotic fishes. And next is the robotic lizard. So this is my favorite area, which this is the first robo which I made as a robotic lizard. When I took it as a challenge to make a robo as small as possible, which is closer to a lizard, but using the components which are already available in the market. So this small I was able to make, and from then on I was trying to mimic the creature as close as possible, and I was trying to publish at various places in India. But if you see NASA also says that we can create Gecko kind of robots for doing some activities on the outer surface of the International Space Station or on the satellites. This is a graphical picture. This is not a real picture. Where the robo, if you see, is stuck to the walls of the space station, space object, and it is trying to maneuver and it's going to traverse on the surface to perform some activity. So this the difference between these four creatures which I chose was this hand is needed for people, humans, basically, to pick and place. This robo is capable of doing anything on land and underwater also. Underwater snake robots are also available. And the robotic scorpion can replace a rover. And this fish can go underwater and search for pollution and other coral leaf studies and aquatic life underwater. It can study. And this robotic lizard has the capacity to climb on walls. So using pressure sensitive adhesives, this is possible to make it climb on walls. So coming to the question of how to build bio-inspired robots. So first choose the application. In this case, there is an application where it has to climb up a wall, which is on the side of a road. This can be for any purpose, but I'm not focusing on the purpose now. We'll just want a robot to go from here to there. You can do it using drone also as well, but still we are trying to use the land way so that it is more effective and requires less amount of control system dynamics. So after choosing the application, we need to look out for animals that can perform the chosen task. So among the, you can, for this, you can look into the encyclopedia on animals so that you can get an idea like what kind of creature is best suited. Then after choosing this, you can try to mimic the mechanism close to the animal. So here is a lizard. I tried to map the mechanism on top of it so that I can create a structure similarly so that I can add the robo components and build a bio-inspired robo which can walk on the floor. Okay. So far, if you have any doubts, you can feel free to ask. Okay. Next is introduction to TRIZ. So TRIZ was invented by a Soviet Union engineer, and it was done in the late 1940s and early 1950s when he was working as a patent examiner. So the TRIZ, what it does is it identifies the patterns of innovation and in the patents, and it forms 40 inventive principles and contradiction matrices, and it uses the engineering solutions for it to find solutions. So what we found here was a biological inspired solution, bio-inspired solutions. We try to mimic the creatures in biology, but here in TRIZ, we are going to use the engineering principles to solve the problem. So this TRIZ would be, all the world's engineering problems could be solved in just 40 ways. That is what they argue. And millions of patents were analyzed using this tool, and it is a well-established theory. This is called as a magical tool due to its resources, and it will be introduced to the, because it is TRIZ is basically a Russian acronym. You can see the name on the top. I'm unable to pronounce it properly. You can see the name on the top. But when translated to English, it means theory of innovative problem solving. That is what is TRIZ is. Theory of innovative problem solving. So the TRIZ method is as follows. Understand the problem as a system, locate the conflicts, identify principles from the matrices, and systematically explore the solution. So TRIZ has 40 inventive principles. It starts from segmentation. Segmentation is dividing the product or the end product into pieces. So for example, a train can be a best example for segmentation. Instead of having a single long cuboid and calling it a train, we have multiple cuboids which are assembled in series and we call it a train, so that it can solve a lot of problems which otherwise could not be possible. So the segmentation is the best example. So if you see all this uh, 40 items, this contributes to the inventive principles. And there are 39 engineering parameters of TRIZ. So that this, while trying to identify this, we'll be trying to find out what are the engineering parameters which has to be moved. Weight of the moving object, weight of the stationary object, length of the moving object, length of the stationary object. So like that, 39 parameters are there. So this is a matrix. I'll be opening an Excel sheet soon. So there are 39 parameters, that is engineering parameters. And the numbers which are inside this, and in the x-axis there are 39 parameters, and the y-axis there are 39 parameters. And we'll be forming a lookup table using this. So this is the table. And for example, I'll bring it to this slide. TRIZ inventive principles. For instance, I'm zooming in a lot. I hope you are able to see it. So weight of the moving object and length of the moving object. So if this is a contradiction, length of the moving object has to be improved, but the weight of the moving object has to be decreased or increased or whatever is it. So the inventive principles 8, 15, 29 and 34 has to be taken into account. 8 is, it is to be anti-weight, 8, 15, or it can be, it could be due to dynamicity, 29. It could be due to using pneumatics or hydraulics. Using pneumatics or hydraulics, we can length of the moving object can be changed, and the weight of the moving object can be lifted. So hydraulic jack could be used. So that is the conclusion which we can get out of it. And 34. Rejecting or regenerating parts. So this regenerating of parts is a principle which comes from the biological creatures already. So you can either reject a part, or you can cut off it, or you can create a new part out of it. So that is what is, even in a hydraulic or a pneumatic thing, we will see a cylinder coming out of another cylinder in a tandem way. So that is how this length of the moving object is controlled by considering the weight of the moving object. So this is how you come to a conclusion where there is a conflict. Here the conflict is between the length of the moving object and the weight of the moving object. So whenever you are building a robo, you are in a particular stage where you find one of the problem would be mostly into power. How power can be used along when considered against speed. So if you see this 15, 35 and 2. 15 is dynamicity, 2 is extracting or taking out. Power and speed can be relatively coincident, and 35. Transformation of physics and chemistry. Whatever transformations can happen in using some physical laws and chemical laws, so speed and power can be changed. So this is a best example and a powerful tool where you can get it, get your answers very easily. By only thing you need to do is you need to find out which is the problem under the 39 under the 39 engineering parameters. The TRIZ will give you the inventive principles according to the two engineering parameters. So now we'll take an example where we will identify the problem. A drone is used for search and rescue and needs a longer flight time. Increasing the battery capacity makes the drone heavier, reducing the efficiency. So as you can see here, this is a Matrix 600 drone which we worked on, and this is a battery which is be fed into the each of the six arms, so that it powers the blade, which is propeller, which is on the attached to it. So defining the contradiction. So here, increasing the battery capacity improves the flight, but worsens the weight and maneuverability. The physical consideration: the drone's battery should be lightweight for better weight, but better flight, but also heavy to provide longer power. So the improving parameter, what we want to enhance is the 19th parameter, energy by a moving object. That is, we want the drone to consume less energy and have a longer battery life. But the worsening parameters, we have two. That is, what is negatively affected is the weight of the moving object. Adding a large battery increases the weight, making the drone less efficient, and the speed. A heavier drone might be slow and less maneuverable. So mapping these parameters to the contradiction matrix, we get these TRIZ principles. So there are the energy spent by a moving object versus weight of the moving object. So this, the first 19 versus 1, 19 versus 9. So this is 19 versus 1 and 19 versus 9. So moving object, energy spent by the moving object and the weight of the moving object. Principle number 35, which is the parameter changes we need to make. And the principle number 2, taking out something. And principle number 28, replacement of a mechanical system. So these three should be done. And the energy spent by a moving object versus speed, a parameter changes has to be made. Principle number 28, that is replacement of a mechanical system. So these two are common, the parameter changes and replacement of a mechanical system. So if we apply all these principles using the contradiction matches, we find suitable TRIZ principles such as use a battery with variable energy output depending on power needs, or you can instead go for a single large battery, use a hybrid power source, that is solar plus battery, or taking out. If you want to replace something, place some energy stored externally, such as a ground-based wireless charging system. So by doing these three things, we can try to solve the problem which we found earlier. And this is another example where the TRIZ application is in development of climbing robots. So the physical conflict is that the length and shortness of the radial and axial dimensions of the wheel, and the technical conflict is the reduction in number of motors versus adaptability. So if you see here, you can see that separation principle and the corresponding separation principles and the inventive principles. For space, one is required, that is segmentation. And that's why this robo has been divided into segments. And number two, separation, taking out or extraction. So there are gaps in between the motor and the screw mechanism or the extension contraction. So these kind of gaps are being created. And similarly, this is being applied to the robotics. So these are the inventive principles which are being used. Okay. Has everyone, this is the part of TRIZ for robotics. If you have any doubts, you can feel free to ask me. Okay. So we have time. We will get into the graphical user interface. Does everyone have the processing software downloaded and the code with you? Hello. Does everyone have the code with you? And one of them has it. How about others? So have you downloaded the processing software? If you have downloaded, it would be something like this. You can extract it. If it is Windows, you can extract it. Okay. So processing is a flexible software sketchbook which was started since 2001, and it was developed in MIT in the US, and now it is being taken care by the Processing Foundation. It is used by students, artists, and designers, also by researchers and hobbyists. So you can download this from the download page. If it is Windows, you can download the recent stable version. And here is a simple graphical user interface. Irrespective of what robo you are making, if the graphical user interface, which the person who's going to operate the robo is not user friendly, then the entire purpose of the robo, even if the functionality is really good, then it's going to be a very big, it is not going to serve the purpose. So by using, I'm not saying that this is the best graphical user interface. This is one of the graphical user interface where people can interact with this robo which is on the table. So this is a camera which focuses on the real robo, and this is the graphical representation of that robo. And these are the three parameters which are being controlled. So this was this. I'm playing this video where you can see the uh, working of the robot. So I'm moving the base, the green portion, the shoulder, and the arm. This is the shoulder again. This is the arm. So only when it is user friendly, it will be, it can be used for by the users. So now we will get into the code. Just try to open this processing and say that open loop mechanism, 5-bar mechanism, and the code for the 5-bar mechanism. So this processing, we are using Java mode. There are a lot of other modes also. If you see here, you can use it for Android mobile development also. You can code it over here, and you can use the same code in Android mobile by just clicking over here and installing the Android packages and a little bit of tweaking. You can just go into that, and you can use it in Python mode also. You can use it in R language and other things. But in today's thing, we'll be using it in JavaScript, basically. So here we try to call the processing serial and control P5. Both are imported. We are defining some variables in float and a float offset. And we are defining some shapes, L1, L2, L3, L4, and base. So these are the linkages. The right link is at 90° initially. The left link is at 0° initially. This is the size of inside void setup. This is the P3D because it's in three-dimensional. We are defining it as a 3D screen, and the smooth is required for smooth translation, and the frame rate is at 30 FPS. This may or may not impact. It depends on the system you use it. The controller which is used this is for slider. This is a slider which we will be creating for X rotation, Y rotation, and Z rotation. These are the various parameters. That is the position of the slider on the screen. And these are the L1, L2, L3, L4, and the base are the links which are open, which links which are being chosen. So one thing is that every file will have a data folder. Inside the data folder, you have the CAD model which was created using Blender. So you link1.obj, that is here it is the link1.obj. And look at the properties. This is the obj file. So these files are called inside, and these are the two controllers which we are using to control the slider. And this is if you come a little down towards the line number 100, we'll be creating a base link where there are two options: push matrix, that is, it starts converting it into a matrix, and it pop matrix, it will come out of the matrix. So this function is used to translate the develop a translational motion, and translate, that is, move to a particular spot on the screen and perform the rotational action by this much. So what happens here is we are setting the right link angle and the left link angle. So that angle is being given over here into the code where we form the simple mechanism. I'm running the code. So the right link is over here. If I move the right link, it's a 5-bar mechanism. This is the left link. And the three things which are over here is, these are the for the CAD model, rotating the CAD model and seeing how it looks like. And this is for controlling the simple mechanism which we created using the processing program. So were you able to try it? Okay. Now we'll move to the next program. This I'm not sure whether it'll open. This CV graph you can try when you're not connected to a video call, because this uses the camera's view. And this this individual LED and RGB LED control, this code you can try by connecting it to the Arduino. This is simple. So now we will try the lizard. The thing is pretty straightforward. Here I will see the output first. So here, this is the graphical representation of a lizard. So this is how you can make a robotic lizard, and you can actually connect it to the Arduino, and you can transfer this data to the Arduino and make it work, like how I showed you earlier. So these are the simple transformations which keep happening for the shape which are inside. You can actually see the body, head, left body, right body, and things like that which are being created. This is beyond the scope of this workshop. We can have a separate workshop on this maybe in future. And this is these are the four control parameters are there. So this is the fourth, third, second, and first controller. And this is a simple staircase mechanism. You can actually try to comment out the camera's portion, and you can try to run it. Now I'm running it without the camera. So this is a simple mechanism which we can control using the software. And this is the 3-axis robo which I showed you. So this is the base, this is the shoulder, and this is the arm. And now again, this is the CAD model. If you want to examine the CAD model, you can use these three and you can examine. So what happens here in this code is we have connected, you have to uncomment this line. This is import cc.arduino, and we have to create a variable for Arduino, and we have to create a how you're connecting, how the Arduino is connected to the system. That path you have to give here, and you can here you can give the base angle, shoulder angle, and the arm angle. Write it to the Arduino. The Arduino will receive the code on the other hand, and it will display the code in the. It will, as you move the cursor over here on this platform. That is, if you move here, that same thing will happen over there in the reality. So that is what I had shown here. That is what happens. So this is actually the lines of code are transferred to the Arduino, and via Arduino it goes to the motor. And coming to the conclusions, and I had given you an introduction about the open loop and the closed loop mechanisms. The basics of electronics were covered. Bio-inspired robots were discussed. The TRIZ principles were introduced, and the graphical user design was done hands-on. And thank you. And these are the 3 books: the computer controlled robots from scratch, TV remote controlled robots from scratch, and voice controlled robots from scratch. These are 3 books which I have written, and it is available on Amazon. And here is a QR code to my LinkedIn profile, and you can mail me at any time. I'll be happy to help you out. If you have any questions, you can feel free to ask me.
Yeah, right. Yeah, so if anyone has any questions, please ask, sir. And thank you so much, sir, for your time, for coming to the session and, taking out time from your busy schedule.
Yeah, thank you. Thank you for inviting me.
So maybe we could wait for like 2 minutes more. If anyone has a question, they can ask, and then maybe we can conclude the session then. Also, sir, if students have to reach you out, how can they do that? Like, could I maybe if they ask for your number or anything, is that possible?
Yeah, you can share. I feel free to share it. Or you can contact me on LinkedIn also. This is the QR code. You can just scan it,
Very well.
or you can
Very
email me
well.
at askvsr@gmail.com. You can feel free to ask.
Very well, sir. I think no one has a question, so I think we can conclude the session here. Thank you so much, sir, for coming to the session, and we really, really appreciate your presence. And I hope maybe we can do something like this in the future as well for the students.
Sure. Thank you.
Thank you. Bye bye.